Welcome, colleagues. Today's lesson, I'm going to look at this question, which was question 2 from your test 1. Said f of x is equivalent to exponent negative mx if x is a member or is defined as a member between negative infinite to infinite, but the same function is 0 if it's not within this range, isn't it? Yeah. So where m is a constant, so m is m can be any number. It can be 2, it can be 4, it can be anything. Now they are saying express fx as the nth Taylor polynomial, isn't it? Centered at what? C equals 0. So for this one, once they just say Taylor polynomial centered at c equals 0, what you just need to know is they are telling you to find most of a Maclaurin polynomial, because that's the only Taylor polynomial which is centered at c equals what? 0. So the first thing I usually advise you to do is f of x is the same as what? As y, isn't it? Which is equivalent to this what we have been given. So this question was so direct. We know that this is at what? At 0, at the starting point, isn't it? So we're going to differentiate for the first time. Then we're going to get, when we differentiate this, we know that it's negative exponent negative m x, isn't it? With an m here. So we know that we have differentiated for the first time, isn't it? We differentiate for a second time, we're going to get m squared exponent negative mx, like that. This will be what? 2, isn't it? We differentiate the third time, we're going to get negative m cubed. This bad, this is for number what? Number 3, isn't it? We differentiate for the fourth time, we're going to get m4, and this is enough. This is enough for us to deduce what the question requires us to do. So what I will do first is I'll make these numbers what? Factorials. And this is a 1, this is a 1, this is a 1. Yes. So I'll just make these numbers factorials for the first part and divide them with what? With their respective terms which they are with. So I'll have this divided by 0 factorial. So that's my first thing which I'll have equal to, have exponent negative mx divided by what? 0 factorial. Then I have a negative here, isn't it? So I'll say minus m, we have that, we have mx divided by, it has a 1, so this one becomes a what? Factorial. Then we have plus m squared exponent negative mx divided by what? 2 factorial. Then I think we can even write this as the last one, which is m cubed exponent negative mx divided by what? 3 factorial. Then we know that it will be plus. So we are saying plus minus plus minus plus. So from there, what do we do next? What we're going to do next, again, these same numbers, we're going to raise them as the powers of what? The powers of x. But now, before doing that, let's let x equal 0 for this, because we know that c is equals to 0, isn't it? So c is equals to 0, meaning x will be equal to 0 for the main functions, which are these ones. So if I put 0 here, 0, 0, 0, what am I going to get? Just going to get 1 over 0 factorial minus m over 1 factorial plus m squared over 2 factorial minus m cubed over 3 factorial. Then I'm supposed to have a plus. It keeps on going. It's an endless list. Now, for these numbers which we have, I'm going to raise them as the powers of x. So have x to the power 0 multiplied by that, x to the power 1, x to the power 2, and so on and so forth. So this becomes 1 over 0 factorial multiplied by x to the power 0 minus m x to the power 1 over 1 factorial, then plus m squared x to the power 2 over what? Over 2 factorial, then minus m cubed x to the power 3 over what? 3 factorial, then plus, we have something like that. So now, this what we have is our Taylor polynomial, which is centered at 0. But now they are saying we need to find the what? The nth Taylor polynomial. So we need to find a formula, of which it will be one of the topics which you'll be doing next in your next academic or that will be next year, which will be your next semester. Now we'll be even advancing to be doing Taylor series. But now even for Taylor polynomials, you can still derive the nth Taylor polynomial. So what do? You just need to observe the pattern which is happening. So for the first part, I'm seeing a positive, a negative, a positive, a negative. So whenever you are seeing alternating, so let's do it there because it won't take time. So whenever you are seeing positive, negative, so we can see 0 is even, odd. So for even numbers is positive, for odd numbers is negative. So whenever for even numbers is positive, for odd numbers is negative, you're supposed to have the summation. We know that n starts at 0 because we can see that it starts at 0 going to what? Infinite. We don't know, it's an endless list, isn't it? So whenever even are positive and odd is negative, just use -1 to the power n. But if it's vice versa, we're supposed to use -1 n plus what? Plus 1. So we can test that. If we get a 0, substitute there. -1 to the power 0 is positive. Well, we get a 1 to the power -1, it will be -1, this will be +2, this will be negative, you see. So that's how lovely this is. So what do we see? We can see that even the x has also carried the same word. For the x, the x has the same power. The x has the same power as m, isn't it? So we can see there is m to the power 1, and this is x to the power 0. We can even say m to the power 0. M to the power 0 and x to the power 0 still give us a 1, which is here. So here we'll have m and x to the power what? To the power n. Just like that. Then we'll say we have over. You can see that the same powers which are there are the same powers we're supposed to have at the bottom as factorials. So before confirming or before saying that's the final answer, you just need to see if it works. So let's say we get a 0, you substitute a 0 there, we'll get a positive. Substitute a 0 there, mx to the power 0, it will be 1, as the same as this. Then 0 factorial, it will be 1. So this whole term will become what? This whole term, when you are presenting your final answer, you can just write this whole term as what? 1. So let's get a 1. When I put a 1 there, I substitute a 1, I'll get a negative, which is here. A 1 there, I'll have mx, which is that 1 factorial. Okay, 2x. Let's go for the second one, just for the sake of testing. You get a 2. -1 to the power 2, that's positive. We'll have m2x2, then we have 2 factorial. So this is the Taylor nth polynomial which we needed. So what you can just do, you can just say this dot then plus, then we just get that and put it here. We'll say -1 to the power n mx to the power n, then we say all this divided by the n factorial. So what this means is this represents the sequence for this. Otherwise, thank you for your attention. See you in the next video. Bye bye.